So hello everyone. Today in this video, we are going to discuss about a simple guide to autoscaling with Keda in Kubernetes. So here, in data-intensive applications, efficiently managing background tasks like batch processing is critical, especially when demand fluctuates. Instead of provisioning state resources, why not let Kubernetes dynamically scale processing jobs based on workload? So in this video, we'll build a scalable CSV processing pipeline where a Python job generates CSV files with dummy data. File names are pushed to Redis list. A Keda scalar job in Kubernetes watches Redis and spins up multiple worker pods to process those CSVs. So Docker Hub hosts our container images and everything is containerized, deployed and auto-scaled with a Kubernetes cluster. So here let's walk through the entire process from structuring the project to deploying it step by step. So here you can see this is the directory structure of our project. So here we are going to use the Python project here. So this will be the requirements.txt for that. So here in this case, it is a directory contains all the YML files and these both are the Docker files. So here let's go through the step by step process. So first let's install Keda in our Kubernetes cluster by using this command. Wait a second. So here let's install Keda. So it got created to check. Let's use the kubectl get pods in the namespace Keda. So here you can see the containers getting created. So it will be created in short time. So now we'll go for the Python scripts now. So first we'll create the data generator.py. So for that we'll create the src directory here, and in that we'll create this both data generator and process csv.py. So first we'll create a directory as project. So in the project, we'll create the src. So in this first, make the data generator.py. So we'll paste this content here. So I'll save it. So here the data generator.py generates synthetic sales data from Jan to May 2020. It creates a CSV file per day under in the data and raw file. So and it pushes the file name into a Redis list, which is CSVs to process. So here now let's create the process csv.py and paste this content here and save it. So here the process cv.py pops a file name from the Redis list. It is the CSV, aggregates total quantity sold by item ID, and writes results to the in this path, which is data processed with aggregator sales.csv suffix. So now let's make the requirements.txt at outside. So here we'll paste this requirements.txt here. So here we are using NumPy, Pandas, and Redis. These are those versions. So I'll save this. And now we'll create the Docker file. So first we'll create the data generator Docker file here. In that we'll paste this content. And now we'll create the CSV processor dot Docker file. And let's paste this content here. So if you see, we got the Python files, Docker files, and the requirements.txt. Now we'll create the YAML files. So before that, we'll make the images. We'll build the images and push it to the Docker hub. So first, we'll use the Docker login. Paste this here. Paste this confirmation code in this. You can confirm. So our Docker got logged in here. So now let's build the images. So here I'll give my Docker Hub's username, and then I'll click on enter. So after that, we build the CSV processor Docker file also. So it got built. Now let's build the CSV processor Docker image also. Here I'll give my Docker Hub username and click on enter. So it got built. So now we'll push the images to the Docker Hub by using these commands. So here I'll give the Docker Hub username and then click on enter. Will be pushed. Now let's push the CSV processor Docker image also. So I'll give the Docker Hub username and click on enter. So after pushing, we'll create the Kubernetes manifest here, which are the YML files. So here we got Redis deployment of service.yml and then one PVC inspection.yml, a data PVC.yml, and the data generator and CSV processor.scale.yml. So here the images got pushed to the Docker Hub. So now let's create a directory here, which is created. So here first we'll deploy the Redis first. So this is the Redis deployment.yml file. So I'll copy and paste this here. Now we'll make the Redis service.yml. So after that, we'll apply them. Where the deployment of service got created, let's check them. So the container getting created. So here the Redis deployment is done. So now what we'll do means we have to note this cluster IP of the Redis somewhere. So I'll note this here. We have to use it in the data generator and CSV processor manifest files. So now let's create the data pvc.yml file. So in this, I'll give this content. So we are using the 1 GB storage here, which the access is read at once. So let's apply it. You have to do it here. Apply this. So the persistence volume got created. So now let's deploy the pvc inspection.yml. So in that, I'll use this content here. So let's deploy it. So the inspection pod got created. So now let's create the CSV cluster scale job.yml. So here I'll use this content. So here we have to change some things. So here we have to give the Redis cluster IP, which we noted here in the notepad. So copy this and place it here. And also we have to change it here. So here we have to change the image name also. So the image name got changed and also the values of the Redis host also got changed. So save it. So now we'll apply this one. So it got created. So now let's create a data generator job.yml. So in this, I'll paste this content here. So here also we have to change the Redis cluster IP. And also name of the image which we push it to the Docker hub. So after changing these two things, we have to save this file and apply. So here all the YAML files got created. So now let's verify by using this command here. So this command will show the scaled objects. Will take some time, so let's wait. So here you can see already all the parts got getting created here. So now let's check again. It's okay. It will take some time. So here you can see the pods are already got scaled here. So so by using this command, you can see it like this. So no need of it as the pods are getting created like this. So just we saw just now. So now here we have to check the CSV processor jobs are actually generating processor files. So let's use this command to open a shell inside there and let's see the run a PVC inspection pod. So first let's go inside this pod and now you can see there are some files here. So here let's go to the data. So here you can see both processed and raw. So let's go to the processed and then in that you can see all the data here. So here if you should see files like this. So if everything went well, to check the contents, use one of the file names from data project folder with the command below. So here let's check the one file here. So here you can see along with the idea and the quantity sold. So that's how it works. So click on Control D to exit. So it's still not coming, but it's okay. So that's how it works. So in the conclusion, this project we built a fully containerized event-driven CSV processing pipeline that automatically scales based on workload using Keda. By combining Python, Redis, Docker, and Kubernetes, we created a clean and efficient system that generates queues and processes data only when needed. So the setup not only saves resources but also keeps your system flexible and responsive, whether you are handling CSVs or other types of background jobs. This pattern can be a solid function for real-world scalable applications. So, so that's about simple guide to auto scaling with Keda and Kubernetes. So that's it for today. So yeah, thank you.